Hello dear viewers, it's troubleshooting time. This branch circuit breaker is tripping. I'm going to find out what is causing this circuit breaker to trip off. The first thing to do is analyze the problem and make a root cause analysis before attempting to open the dead front panel door. Caution! This is not a DIY work. Do not attempt to do this job if you are not a skilled electrical tradesman. First step is to reset the breaker. If it doesn't make on, then proceed to the next step. Open the dead front carefully. In order to avoid tedious and repetitive work, by elimination method, I have reduced all the possible causes into 3, which is most likely to happen. A quick assessment on the total connected load in the circuit shows that the circuit is not overloaded. Now I have reduced the possible problem into 2. The third step is to disconnect the line in the load side of the branch breaker for your own safety and protection. Always be careful not to make your bare hand in contact with adjacent live wires while working with an energized panel. Make a one-line diagram of the circuit at fault. This will help you analyze and locate the fault easily. You can see that there are 3 loops of convenience outlet that converge in a junction point. This time, I took my ohm meter and get the resistance at test pointer. The ohm meter shows a low resistance value indicative of a ground fault around the loop. In order to determine where the ground fault originates, you need to isolate the 3 loops at the junction point by disconnecting point B, C, and D. After testing at point B and C, the ohm meter shows an infinity reading, indicative of an open circuit. Therefore, I can now rule out that loop B and loop C are fault-free. The remaining loop D can now be concluded as the fault originator. It could be coming from outlet number 7 or outlet number 8. Let's find out. So after opening device number 8, finally, I have found the main cause of the problem. The terminal has loosened and the terminal block has melted down together with the wire insulation, thereby touching the metal stud inside the utility box. This is called a line to ground fault. After I remove the defective device, I'm gonna make my final test on each loop for open and short circuit test before switching back to power. In this method, I'm going to use a shorting lead to be plugged in at every point in each loop. This method can be performed in several ways, whichever is convenient for you. Here, in this case, I spotted a male lamp socket and a soldering lead. I'm gonna make this as my shorting lead to be plugged to every outlet around the loop. To do that, you need to short the 2 pole of this socket using a soldering lead wire, as you can see here. Warning: do not plug this shorted pole if the circuit is energized. You can only do this for continuity testing with 0 voltage at the sending end or load side of the circuit breaker. As you plug the shorting lead into the outlet with the test probe at the loop B, the ohm meter should read a low resistance value. After unplugging the shorting lead, the ohm meter should show an infinity reading, which indicates that the circuit is open. Repeat this procedure up to the last device. After testing all the 3 loops and concluded that the fault have already been isolated, I joined loop B, C, and D together inside the junction box. Now, it's time to terminate the branch circuit conductor at the load side of the circuit breaker. Here, I test the voltage at the load side to see if there is a leakage current while the breaker is in the close position. Now, everything is ready. I'm going to switch on. Please don't forget to subscribe for more similar video content, educational material, family, people, events, and general interest.